In the beginning, there was nothing, which did not move. But there can't be nothing without something. So some things balanced the nothing, and they were moving. Those small somethings came together to create bigger somethings. One of those was man. Man found man's self on Earth, where there was a really, really big mountain. On the top of this mountain was a wise master at the tippy top. It kind of looked like a blob. Man asked,
"Who are you?"
I am Master.
Okay. How did you get up there?
There are many paths to the top of the mountain.
I don't see any.
Come closer.
I don't see how.
Come on up. Just climb up. Seriously, don't be a sissy.
It's too hard.
Then take the ladder.
What?
There's a ladder right over there. Seriously. Hurry up, this party is lit.
But what if I fall? I can break my back or get a scratch in my teeth.
Are you for real? Then take the elevator. It's over there.
Oh.
and man took the elevator to the tippy top. When he got to the top, he had the time of his life enjoying the party, and he wondered how it was all possible. The master told him it was because of the power of the microchips. These were programmed and controlled the motors and colorful LED lights that made the party hot fire. So man dedicated himself to study the secrets of the chips, but was very frustrated because it was really, really hard. It was so hard that man was split into two, as there are polar opposites for everything. With these two polar opposites, they made copies and copies of man, who studied and later lost the secrets of the microcontroller chips. These secrets have been passed down for millennia by a select few, and now they are yours to know freely. At least how I understand it.
Machine. Correct score 10 out of 10.
Hello and welcome to KimchiRobotics, the best place to learn robotics for beginners in the fastest, cheapest, and easiest way possible. Today we're going to jump in head first. We're going to be covering microcontrollers because any robot that's worth its salt is going to have a microcontroller at the heart of the build. These are programmable in various languages. However, the best one that I recommend, especially for beginners, is the C language. There's many reasons for that because you can talk to the hardware in a better way than you could with something like the Arduino IDE or C++. Here is the Arduino that you're probably familiar with, and the reason we don't want to use that, well, just take a look. That's too bulky. What do you want? Do you really want this? Do you really want to use this? Do you really think that this is good for your robot builds? You're going to have another square robot, just going around like just like everybody else, and it's going to be big, bulky, and unnecessarily overclocked. The reason for that is this little crystal oscillator right here. This jumps the AVR chip's capabilities from 8 megahertz maximum speed to a blazing 16 megahertz, and that is completely unnecessary, especially for beginners. You don't even need the full 8 megahertz for most applications when you're starting. These chips come clocked from the factory at 1/8 of their total speed. 1/8. So that's 1/8. 1 megahertz. 1 hertz is basically 1 cycle per second. So 1 clock cycle per second is 1 hertz. So when you hear about hertz, that's what that means. And these chips are capable of 8 megahertz by themselves maximum. You can add a crystal oscillator to jump that up, but you don't need that, okay? That's for like super high accuracy applications. And these chips are going to come from the factory at 1/8 of the speed, 1 mega. That's 1 million hertz. And that's plenty for most of what you're going to be doing, unless you start getting into things like servos and other kinds of sensors and high accuracy calculations, but you don't need that, like I said. Another thing that you'll notice about the Arduino board is they have these very tall headers, okay, these header connections. These are just things that you can stick male header wires into very easily and simply, and they are good. They're very convenient, and you can get basically a smaller version of the Arduinos, like the Nano, etc. And Raspberry Pi has the equivalent. They have the Zero, which is fantastic. However, you do not need to know all this. You don't need to have all this. You don't need these capacitors. You don't need this USB connector, and you don't need this power connector. This is all a lot of unnecessary stuff. Here you can see the actual AVR chip is seated into this slot that they have provided here. And all of these headers are just connected to each of these pins, basically. You're probably familiar with the Arduino. If not, don't worry. We have analog input here. Analog is for the various things that have real-world electrical values. You're working with electricity here, and the real-world electrical values can be sent in here. The analog to digital converter is going to change those values into digital values that the computer can then work with. So when you look at these chips, think of it as a computer, basically. It's just the same as your potato PC that you try to play Minecraft on from 12 years ago. It's the same thing, except it's on a much smaller scale, and it's very incredible what you can do with it. The Arduino also has its own wrapping on top of C++ and C, which is called the Arduino language, and you work in the Arduino IDE, basically. You're probably familiar with that. If you're not, it's basically a simplified version of how to communicate and write code for this chip here. This is the heart and the brains of all of this that's going on. And so why not get rid of all of that and focus solely on the chip itself? You can immediately see the form factor of your robotic creations. At least you can see how much space you can save and make much smaller things, which can fit later on onto small boards like this that you can cut up according to your needs. Your chip also has built-in peripherals. And what are these? These are basically pre-made, prefabricated functions and hardware features, etc., and protocols that can do very useful work that you're going to be using time and time again. Overall, you can call them SADIT. That's the little acronym that I've made up for myself. The first one is serial communications. So there are different kinds of serial communication protocols. Think of these as, I guess, kind of like different languages that you can speak to different sensors and different microchips and even to your computer. There's UART, USART, there's I2C and SPI protocols. They all have their own different benefits and disadvantages, and that's beyond the scope of this video. I just want to let you know that it has serial communications capabilities. The next one that you need to know about is the analog to digital converter. This is a great one. Basically, it will take real-world electrical values that's coming into the chip from a sensor or potentiometer, etc., and it converts that into digital values that the chip can understand and work with. And it's great. It's very useful and handy, and that is included, and you will be using that very often. The next one that you really need to know about, and that's very crucial in all of this, is interrupts. Interrupts, basically, think of them as a trigger. You set up a condition in your code to perform some sort of work or to stop the program, etc. Think of like when you push a button you push the button and you set up a condition in your code beforehand so that if you push that button, it will perform some sort of work. It'll stop everything and perform that work, get that job done, and then it'll go back into your normal code and, go through the cycle again. The last peripheral you need to know about is the timers and counters peripheral. This goes hand in hand with the interrupts. They work together oftentimes. And timers and counters, you can use that to count button presses. Obviously, a counter. You can set the counter to use the counter to set up a certain frequency, or how many times or how often you want the pulse to be generated on a certain pin, like when you do pulse width modulation, or PWM for short. Timers, they set the frequency and things like that for the pulse width modulation that these chips can do. It comes in handy when you're doing motors that can rev up and rev down instead of just turn on and turn off. Also, it helps LEDs glow on and off, and there's just so much more you can do. And you can even simulate AM radio by setting up a really fast PWM pulse. And anyway, there's just so many things you can do, and you're going to be using it a lot. It is a little difficult, and each of these are going to need their own separate videos, which I will be making in the near future. So let's take a look at the AVR pins. I have a diagram here on the screen for you, and I'm just going to put this over here. The diagram is going to go over all of the pins. So you'll notice that there are 14 pins on each side. There's 1 through 14 starting at the top. We know this is the top because you can see there's a divot. There's a divot at the top. That's basically north. So if you have a compass north, that's the top. So we start counting from the divot on the left side. There's another divot right there, right? A little indentation. You can see that divot at the top, the two divots. So basically that's pin number 1. We're going to start counting from this pin onward. So I'll put this on the side here for you. We have pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 1 through 14. On the other side, we start from 15 on the bottom. So it goes counterclockwise this way. Okay, counterclockwise. 1 through 14, 15 to 28. Now, if you look at the pinout diagram, you'll notice that these pins are all over the place, basically. There are different groups that I've colored for you here. The first thing that you're going to need to know is the middle pin 7 and 8. 7 and 8 are where your voltage is going to come in on pin number 7. It's red, so you could use a red wire just so you can organize it well. That's the voltage that's going to come into this chip. And the ground also needs to come in. So just think of it as water. Electricity can flow if it has somewhere to flow into and somewhere to flow out to. Just think of it that way. That's the easy way to do it. So pin number 7, you can color it red like with a marker if you want, and pin number 8, you can color it black as well. On the opposite side, you'll notice that there is also a ground pin, but that is for the analog. That is for analog. I just talked a little bit about analog. The analog is going to be used with those pins. There's analog, there's ground, there's analog reference, and then there's analog voltage in. Don't worry about that for now. We'll get into that later when we start using analog devices and components, etc. So looking at the diagram that I have on the screen here, you'll notice that there are 3 different groups of pins. All we're doing when we're working with these chips are working with voltage in and voltage out. The voltage comes in, right? The electricity, the current flows into here. The water flows in, and while it's flowing out, we can send that current out, or we can listen for current to come in. Okay, just speaking and listening. Just think of it very, very simply. This stuff is very complicated at first, but when you think of it simply, you're going to understand it much faster than anybody else. So here we have the pink bank of pins that I have labeled as DDR-B. This is the Data Direction Register B. This is going to come into play when I show you how to program an LED to blink on and off. I'll explain that a little bit more in the next video. Just know for now that there is a Data Direction Register B, a Data Direction Register C, and a Data Direction Register D. Okay, so with the 328P chip, we have the B, C, and D data direction registers. This can be thought of as a street. So if we're looking down at this chip, Basically, you're looking from a satellite view, like from space. And when we zoom in, you can see streets, kind of like Google Maps. You can see the streets. Those streets are the DDR-B, C, and D streets. On those streets, we have houses, and these are called the pins. So we have PB, pin B, 0. With computers, often we start counting with 0. That's just how it works. And actually, when I was in second grade, I counted from 0. In first grade and second grade, I started counting from 0. We had a number line on our desk, and I would count from 0. No lie. And I failed all my quizzes, and my teacher talked to my mom and said, hey, he's failing his quizzes. And she was like, why do you count from 0? And I was like, because it's part of the number system. I was right, and I'm glad that I can use that fact in this hobby now. All right, so going back to the topic. So we have PB0 all the way through PB7. And you'll notice that, look, it jumps from 0, 1, 2, 3, 4, 5, 6, 7. Okay, so look at the pin numbers if this is confusing. So look at the actual pin numbers. Remember 1 through 14, 15 through 28. And you'll notice how they separated it all out kind of like this. They have good reasons for this. There's a lot going on inside this chip. In fact, let's take a look at the diagram. This is basically the diagram on the Wikipedia page. You can see this is the cutaway version of the square embedded style chip. It's slightly different than this chip, but they're basically the same thing. And the embedded ones are used in PCBs, like you can see on this Arduino board here. This is basically the embedded style versions of these chips. I'm not saying that this is the same exact chip. I'm just saying this is what those look like. When you think of embedded, just think of something that's, soldered onto a board, something like, these chips, okay? So looking at this, what does that look like to you? That looks like a city to me, right? Is that not a city? Look, you got these roads, and you got tons of these little tiny houses, and you got nicer houses over here, and then you have, these, I don't know what this is like the business district. This looks like Wall Street right here. Central Park is probably over here. This looks like a city, right? And basically it is. You have a city full of people and locations, and they do work. They move around, they exchange data, they communicate with each other. So hopefully that helps to make this a lot easier for you to understand. There is no reason for anybody to not understand this on a very, very simple level. And that's why I'm here. That's why I'm making these videos, because I don't see anybody else doing it like this. They're not explaining it in layman's terms, and it gets really boring and people get lost. I got lost. So if you got lost in those videos, I'm glad you came here. I'm going to be doing my best to show you everything that I've learned over the years while working with these amazing little chips, and then hopefully we can grow into bigger chips, badder chips, and make some really badass kind of robots, because nobody else is really pushing that. And I think automation is the future, and automation tidal wave is coming. It's coming. It's a giant tsunami, and it's going to absolutely flood the job market, and whoever's not ready is going to be left behind. Okay, that's all I have to say. You either have to understand how the robots work, how to make the robots. Robot is basically automation, automatic systems, automatic programs, algorithms, automatic machines, new inventions. There's just so much opportunity, and the world is demanding it. And I'll explain that later in another video about how automation is taking over the job market. And it's not scary. It's actually an opportunity, and people have been warning and trying to tell you that you need to get ready for it, and now is the perfect time. So I hope to help in that respect. All right, going back to the chip. So we have our city, and that is why everything is all spread out the way it is. There are electromagnetic interferences going on, and they have to make certain paths around that to try and combat that. There's a lot going on in this chip, and it's amazing that it doesn't overheat and fry itself, kind of like your potato PC. So we have the DDR C, that's the green chips over here, or the green pins over here, and then we have the D street with the D pins over here. These are basically just houses. Just think of them as houses. And in each house, they have a unique family. And each family has its own culture. And each family with its own culture can do different things, right? If everybody was the same, we wouldn't get much work done. Life would be a little bit more difficult and kind of stale, right? So inside of each of these pins, they have different abilities, and I'm not going to cover that in this video. That's a little bit too much. Some of these are hardwired for pulse width modulation, which turns on the pin and then turns it off and turns it on and turns it off at certain frequencies. You can program it for certain frequencies and certain durations, okay? Pulse, width, and then modulation means to change it, okay? So on, off, you know. So that comes into play when you want to like speed up a motor slowly and then slowly speed it down. It also comes into play when you want to glow an LED light on and glow it off. Really, really cool. But actually the fact is you can pretty much get pulse width modulation to work on any of these pins. We also have the analog input pins. You saw that on the Arduino here basically, right? You saw these? That's up here. That's what these are. And it's kind of funny how they're up here and the Arduino people routed it all the way down to here. I mean, it makes sense. This is fine. It's just interesting how they decided to do that. Like I said, there's many reasons why they decided to do these things. So just accept it and get used to it. Last, we have the DDR-D street, right? Street D. And we have the pins, PD, okay? So just remember, the B street houses are called PB, okay, pin B 0 through 7. Then we have the street C with houses that are called pin C, okay, pin C 0, you know, through 6. There's not 7 because, you know, we're using up pins over here, so I think they had to sacrifice one. And then we have the street D, okay, and the D pins, so it's called PD 0 through 7. So I hope that clears up a lot of confusion about the pinout of these pins. And just remember, we're only working with electricity. That's all of it. And if you get overwhelmed at first, don't worry. I was too. You're learning basically simple mechanical engineering. If you've never done this before, you're learning simple mechanical engineering. You're learning programming in the C language, which is a little bit difficult because it's more, it's not as easy to, like, grammatically for humans to think in when they are programming something like C++ or other languages. However, you're going to have a great advantage because you're going to be able to talk to this chip and turn on things that you can't do very well with the Arduino. A lot of people have problems with the Arduino because they can't control it. There's nothing wrong with the board. There's nothing wrong at all. Like, all this stuff is just, aesthetics and, my personal preference because they're just too big. But there's nothing wrong with the Arduino. Well, it depends on who you ask. But it's fine. And especially for beginners, it's fine. However, I think it's holding people back. It's a bottleneck. This giant board is a huge bottleneck, and I think it's time for people to learn what's really going on, really create something amazing. And you can move servos, you can move motors and LEDs all with just the chip. Can you believe that? Can you believe that you can do that? Imagine all the stuff you can create. You can create wearables. You can do all kinds of things with just this chip and a battery source, like a battery pack or 2 battery packs. And we'll get into that later. If you need extra help, make sure to check out my site. It has a little bit more information. It's a work in progress, but I think you guys and girls can really benefit from visiting that site. It has some information that I may forget to cover. I'm going to make a lot of videos on this topic and everything that I've learned. And in the next video, I'm going to show you how to set up the software to actually program these chips, and then I'm going to show you how to write your first program in the C language, and it's going to be great. You're going to learn how to actually do all of this stuff. So when you feel down, don't worry, just visit my site, come back to these videos that I'm putting out here for you, and just know that although I can't troubleshoot all of your problems in the near future, there's going to be hopefully more people who come and who can answer your questions. That's really how it works. And it's going to feel really good when you can start to share your own builds together and just talk about certain problems. Because when you go to these websites that have the quote-unquote, experts and professionals, they are very mean and just callous and cold. I guess that's how, scientific, logical, engineer-type minded people are. They're very boring for the most part. Go ahead and say what you want, but they live in a different world basically. I'm more creative, I'm more artistic in the way that I think, so I think I can help bridge the gap there for a lot of people. And when you're feeling down, just remember to tell yourself,
I'm the smartest guy I know.
make sure to like, favorite, and subscribe, and I will see you very, very soon.